My name's Simon Pulley, and I'm joined today by Charlotte Chivers, who's a PhD student at the University of Exeter. And we're going to run through today a sediment source fingerprinting tutorial type video. We're going to keep this quite casual because it is just really a Skype call we're doing where I'm kind of going for a few things with Charlotte because it's kind of related to her PhD. But we thought as we're doing it, we may as well film it because I'm not seeing any other sort of tutorial type thing on YouTube at the moment. So hopefully this will work successfully and it'll be the first. My background, I did my PhD about 5 years ago, and that had a lot to do with like sediment fingerprinting, and I've done a fair bit of research on that and other things in the 5 years since. Today we're kind of going to work with a tool called SIFT, which I've developed while I've been working at Northampton Research with AD Collins, and it kind of takes you through a whole sediment source fingerprinting type exercise. So Charlotte, do you want to say a little bit about what you're doing for your PhD?
Yeah, so I've just entered the final year of my PhD, and I'm exploring more of the social aspects of water pollution. So I've been interviewing farmers and farm advisors about how advice provisioning could be improved in the future with a focus on catchment sensitive farming. So sediment is something that's obviously of interest because it's one of the main pollutants which contributes to the problem. So I'm interested in whether or not farmers would like to see more of this scientific evidence in future. So SIFT could be a really good way of presenting that data to farmers and other end users, hence my interest in the software.
Cool, perfect. Yeah, I have run through this, I think, once before, like a year or so ago with you, didn't I? But
yes,
it was a very long time ago. And this is kind of what we're going to go through today. It's like an updated version of SIFT. So I did the first version, and when did that come out? I think we did a paper on it 2018. And the software worked. I use it quite successfully, but the original version could be a bit confusing. It bombarded you with a lot of options at the beginning, if you remember.
Yes, yeah. I'm looking forward to seeing the new version.
Yeah, and it's quite hard to make these sorts of things work well with every data set as well. So various people have tried it out and things. So I've kind of gone through, and anything that can cause problems or make it crash, I've hopefully got rid of. But I think if you're following this video and you do have any problems, best thing is just to email me because I can only test it with the data sets I've got, and if we've got kind of if your particular data set causes an issue, I'm not going to know about it unless you tell me. We're going to start off from the very beginning and kind of assume we don't know anything about how to use R, how to install it, how to install packages and set up all the software. So I'm going to give you, Charlotte, the instructions.
Yeah.
And you can follow on and actually click the buttons and do everything. And we'll see how we get on.
Excellent. Perfect. Okay.
Cool. So first we need to go to Google, just any sort of web browser. And the SIFT software uses R, which is kind of an open source programming software, which is quite a complicated thing to use. At least I found it was when I was making this. But once you get used to it, it's very useful. But if you're new to using it, it's not kind of a click buttons sort of graphical interface type thing. It's all command line driven, so it can be quite hard to approach for the first time. So I think if you just type the letter R in, I'm hoping that comes up with, yeah, there you go, the top one there.
UK. Yeah. So is it?
Yeah, I think so.
Download R for Windows.
Yeah, cool.
Excellent. So I think it's just downloading now.
Perfect. Cool.
So yeah, so it's quite self-explanatory how you download it. So just click through the buttons until it gets to a point where you get to this where you can download it. Here we go. Okay, so agree to those. Sign your life away. There we go. Okay, here we go.
Cool, perfect.
Okay, so it should have downloaded now. Here are
Perfect.
so
Yeah, cool. Right, that's all done. So you need to go back to your browser window, and we need to download RStudio as well. So this SIFT software, it uses a add-in called Shiny, which gives you a really nice kind of graphical interface to the whole fingerprinting software. So it's rather than have to type in various code for stats tests and manipulate data yourself, it will just give you nice buttons and sliders to manipulate to do it that way. So it should be a lot more accessible and user friendly. I mean, I find when I remember when I was doing my PhD, I was running and mixing models for months and months, kind of 12-hour days doing all that. And kind of if I'd had this software back then, I could have done it in a fraction of the time.
so yeah, I've just downloaded a free open source license RStudio desktop.
Yeah, that'll do.
Yeah, that's absolutely fine.
Yeah, so we did a few years ago. A group of us, I think it was me, Ian Foster, Amy Collins, Paolo Porto, Alan Gellis. I don't know if I'm forgetting anyone else. We did a review paper on sediment fingerprinting. And I think it's kind of Collins et al. 2017, and it's called something like Sediment Fingerprinting for Catchment Management, where we kind of did put in, we wanted to kind of give a user a guide for a sediment source fingerprinting methodology. So we made this nice decision tree with all various stages of the methodology where a user could kind of follow along them, hopefully. And it came out quite nicely. I think it was something new and novel to put in a review paper, but from talking to people afterwards and looking back with hindsight, it was quite a large document, that thing, and had a lot of different steps which were quite complicated. And if you kind of think about them from the perspective of like a new user to the methodology, it'd be quite hard to understand what all these various calculations and considerations are. So I've tried to move a lot of that as well as some new things into this software so a user can do it at a click of a button rather than having to kind of work out how to do various coding parts of it to get, say, a mixing models working properly.
So yeah, so RStudio has now
Okay,
also
perfect.
installed.
Right,
Okay.
that should be all we need to install. Occasionally you can run into a problem where you need to install a certain version of Java to make it read Excel files properly, but most computers I find don't really suffer from that. So if it comes up in this tutorial, we'll look at it, but chances are it won't for a user. But if it does, there's a note in the instruction file that comes with the SIFT download you can read to fix that one. Okay, so once that's done, you can I think you can probably leave your email open for now.
Yeah.
But okay, no, sorry. What we need to do is go to the Rothamsted Research website where we'll download the SIFT tool. Yeah, so if you write in Rothamsted Research and write in SIFT afterwards or something like that in Google, perhaps. Purely just because I can't remember where you go on the actual site. There you go. That's it. Perfect.
There you go. It comes up straight away.
Yeah.
That's good.
That's it.
Now, yeah, I pop in all my details.
Yeah, you don't have to. I mean, we don't actually need to fill this in because so what
No?
I've done is emailed you an updated version of this SIFT tool,
Yeah.
which I finished a few days ago.
Okay. Yes.
And it's
Yeah.
not actually on the website yet, but for
Yeah.
anyone following along with this, it will be.
Will be
Yeah.
okay. So anyone who is wanting to use it will go through this, and it's
Yeah.
just here, isn't it? So you just click here, and it would download.
Yeah, so you fill in this form like you have done, and you'd click the submit button.
Yeah.
And what happens then is it will email you a link to download the software. So it won't come up with a direct download. So you'll get an email, you'll click the link, and that will let you download it.
Yeah.
It's worth noting, for some reason, even on kind of my own email address, which is a Rothamsted Research one, it still somehow blocks that download link and puts it into the junk folder. So if you don't get the email, check your junk emails, and it might well be in there. But what you'll get when you download is like a file, like I've emailed you there, and you can see in your Outlook a zip file. I'm sure, I think everyone has WinZip installed on their computer, so you should be
Yeah.
able to unzip that without any problem. So if you take that folder and just copy it onto your desktop. Yeah, cool. Cool, open it up. Now we've installed everything and got this folder. The first time we run this software, what it will do is install lots of what we call R packages, which are little add-ons to R, which fulfill different purposes. It might be a specific stats test or ways of moving around data. But virtually everything you use in R will use these packages. And when we run it the first time, we need to install all of those. So the software will itself just install them when you click run. But I do find occasionally you'll run into a problem where it doesn't like to install one that way, or for some reason it just wants you to install it manually. So we'll go through the slightly longer way and just install these packages ourselves before we start. So if you click on, you see there's a little folder there that says install packages.r. If you open that up, so you'll see it opens up in our studio. Cool, that's probably where you've just run SIFT the last time. So it quite often tries to reopen what you were last working on.
Last time, yeah.
And you see we've got this big block of code in the top. And all that does, it takes each package the software needs, checks on your computer whether it's installed, and if it's not, it will install it. So what you can do is if you hit the source, you see there's a button that says source at the top?
Yeah.
Yeah, if you click that, what it will now do is go through and install all these packages. And the advantage of doing it this way, you can see it's kind of scrolling all this text in that bottom box. So if there's any problems or errors, it will let us know that. If you run it just through the software, I mean, most of the time that will work fine and you don't need to do this. But if there is a problem, it tends to just crash back and close the window, and you don't really know what the problem is. Cool, I think you've had installed this before and had lots of... and most of these packages are already on your computer, because normally that takes a long time.
Yeah,
So
yeah.
that's
So
good.
I deleted everything, but it must have it must have maintained some of it. Okay.
Okay,
Cool.
so if you leave that open now, I mean, one thing we find with R is these packages tend to be updated every so often. And most of the time that's fine, but occasionally you'll get one of the packages might be updated, or something might change so it doesn't install properly. So what I want to do is just let's just imagine one of these packages hasn't kind of installed properly, and I'll show you how to install it manually. If that is the case and you go to run the software, you'll open a separate SIFT window up. It will flash up for a minute and then crash back to this screen you can see here, and you'll get a line of red writing here. If it says warning, that's generally fine, but if it says error, it might say a specific package name, and you can see them in kind of quotes there, like you've got tidyr, lifecycle,
ellipsis,
dpylr. I mean, if you were to see a message saying tidyr could not be found or something like that, I'll show you just how to install that manually, which would fix the problem. So I think if you go to Tools at the top, and install packages, and then if you type in, say, tidyr, just as it's shown at the bottom there, and click install, and you see it just installs it that way.
Excellent.
Cool, so that's done. So chances are, and hopefully no one will need that, but just for completeness, so you know how to do it, if you get an error saying it can't install a package, that's just what you do. Okay, so we should all be set up and now I'm ready to run things. So we just want to check this works. So if you go back to the SIFT folder you have, And you see you've got that file there that's called app.r. If
Yeah.
you open that one up, perfect. So this is the code to actually run the software. There's lots of other files with bits of code which do specific functions, but this controls everything you see on the screen and all the displays and outputs and things like that. So the way we run it is, you can see at the top of that box there, there's a green arrow that says Run App.
There we go.
Okay, so you want to click that, and just if you just leave it for a minute, you'll see it after a while. Yeah, all these boxes come up with the colours at the bottom, the instructions and things like that. So normally if you get to this stage, it means you've kind of installed it all properly and it's working. So if you just close that for now we know that it works. Send it away. That's fine. So if, for example, we had a package that wasn't installed properly, where the red text is at that bottom window there, it would come up with an error message. So yeah, if that happens and you struggle, just email me and I'll give you some instructions to fix that one. Okay, so now we've got everything installed and we know it kind of opens up okay. We need to put our data in which we're going to analyze. So if you go back to that SIFT folder which we downloaded, and you see we've got this input.xls file.
Yeah. Open it?
Yep, open that up.
Okay.
Okay, so if you click the enable editing thing so we can work with it. So all of the data that you want to work with will go into this sheet. So it's really the only data you'll type in the whole process will be here. And it comes with this data set preloaded, and this is what I generated using that drawing my PhD. And it's for the Nen River Basin in Northamptonshire. And I think for this tutorial we'll probably work through and use this data set. And it'll be nice because anyone who downloads it will kind of also have access to this. So
that makes sense.
Yeah, perhaps before using their own data set you could work through this one just so people know what they're doing. So you can see in this sheet we've got various columns. So in A we've got names. So that's just the name of a particular sample. And it should say on this input sheet, this is the source samples. So if you remember, I think you've come out with this and done this before, or with Harry perhaps at Northampton, where when we're doing a sediment fingerprinting exercise, we'll go out into the field and collect lots of bags of potential sediment sources. So maybe like cultivated land, channel banks, grassland, anything like that. And so hopefully when you collect each sample you'll come up with you'll give it an individual name, and I've kind of given these they're kind of based on where I got them. I think I've slightly changed my naming schemes in recent years, but you've got stuff like Buckby Urban, which was collected in, I think, Long Buckby Village, that one's from.
An urban source. Yeah.
So this is kind of, when we're at this stage, we're assuming you've gone out and collected all your samples, else you won't have data to put in. And we're also assuming you've measured all the different traces within those samples to get to this stage. And in this data set, we've got various types. So we've got our element concentrations there at the end. We've got various radionuclides. There we've got cesium-137, lead-210, and various lithogenic ones. I mean, lucky those were measured where I did my PhD at the University of Northampton with Ian Foster. He's got a nice variety of gamma specs which are incredibly useful for various pieces of research. And we've got various magnetic measurements in columns F through J.
These ones.
So it's like low frequency magnetic susceptibility in the first one, through to is that hard isothermal remnants magnetization, I think. Okay, so for each sample what we've done is noted down the X and Y coordinates where we collected it from. So I took out a GPS to do that. I do find quite a few people won't take those measurements, and in that case, that's fine. We can still work with the data with this.
You can often use Grid Reference Finder too. So I use a postcode batch converter.
Oh yeah.
Yeah. So that's how I do my GIS data and get XY data by just inputting the postcodes, and then you can see the rough XY coordinates.
Yeah. Oh, that's cool. Yeah, I mean, it depends on the scale, I guess, of the
yeah, that's the thing. Yeah,
in,
because if it's very specific, then it wouldn't. It would just get the postcode. But yeah.
Yeah. So I think the important thing with these XY coordinates is they need to be in kind of like a numeric type coordinate system. So if you type it in with like degrees, minutes, seconds from Google Maps or Google Earth, that won't work. They won't like reading them.
No.
You'd have to convert it into, say, decimal degrees, or in this case, it's a British national grid.
Yeah.
So as long as it's like numbers, it should work fine.
Yeah.
You can even just make up your own grid over a site and just anything numeric. So for each sample, we want to put in those coordinates. If we don't have XY coordinates, what I do in those columns is just like put a sequence of numbers like 1, 2, 3, 4, 5 right to the bottom. We don't put, probably best not to put like the same number for them all, but just put some different numbers in or a sequence to fill the columns. The important thing in here is we don't want to leave anything blank or put in any text or anything like that. So in columns D and E, you can see for each sample I've given it two names, land use and geology. And they're all urban at the top, so I've kind of put, it's kind of hard to know what to put for geology with urban. I tend to treat it as its own thing, but you see the actual soils have proper geology names. Yeah, the original SIFT version, you had to do these by number, but I found it's a lot easier now where we can label them by name.
And then channel banks as well, yeah.
Yes, yeah.
Grassland.
Yeah, I'm always like never sure whether to put channel banks as like its own geology or just treat it as whatever geology the channel bank was over. I guess it's kind of down to the user, I guess.
Yeah.
I mean, often it's worth just running the software twice and actually trying it with different combinations of these names. I should mention I've called these land use and geology, but I mean there's nothing to stop you putting like soil types in the columns instead of geology or anything else you want. It's just kind of, I put them in as they tend to be what I use. So an important thing is the column headers A to E must stay in exactly the same place. You can't like change their name or change the order or edit them or anything like that. So if we were to type in our new data, what we do is just delete all the data from column 2 downward, row 2 downward, so it's a blank sheet, and then type the names in there, put the X and Y in there. So you just keep in that same format. Yeah. So columns F through to the end, we can actually do anything with those. So if we were working with a news data set, we'd delete all of that data. And we can rename the top row headers by whatever traces we've measured.
Yeah, I suppose a lot of people may have completely different traces or not as many. Or
yeah, that's true. Yeah, we were quite lucky in this data set. I had quite a lot of traces.
I was going to say, this is quite a few.
Yeah, there were actually more than that. I just went through and if that's a good point to make, it's worth going through your tracer data set and actually looking at it before you do this. And if you've got values that are particularly low or you've got values that look a bit dodgy, it's probably best to delete that tracer. So I've had people send me data sets before, and there's nothing wrong with it, but it's where you've used a technique and the tracer values in the sources are very close to your measurement error. So you have lots of zeros, like cesium 137 there. It's I mean, we're talking about some urban sources and channel banks, but we have some zeros in there, and it's fine if you've got a few, but if you find kind of like half the measurements are like 0 or something like that, or the same number, it's probably best to delete that tracer and just kind of use measurements that you're confident in. Hopefully that should be explanation enough to how to fill that one in.
Mm.
Um,
What
so,
is here? Are they?
okay, so I actually just made a mistake. So I was working for a time setting this up with, so you could use isotopes, and to do the mixing
Okay.
model with those, it's you get a thing called like concentration dependency.
Yeah.
I actually never finished that code, so I think when it's downloaded, that isotope concentrations tab won't be there.
It'll be there. Okay.
It
All
might be in
right.
a later version if I actually get that
So the
finished,
coding.
but
Yeah. Okay.
it
Excellent.
tends to be with something like this. It's like you can keep going forever for adding new features, and I kind of
Yeah.
decided I'd best stop and just get a version finished.
Yeah. I get it. Yeah. Well, we'll ignore these bits
Yeah,
then.
that's cool. So, but we do need the sediments tab down at the bottom.
Yeah.
Okay, so
Excellent.
in that you've got names. So again, you want to give each sediment sample its individual name. We don't actually put in any like X and Y coordinates for these, just because I kind of haven't quite set up the model to do that yet. I probably will eventually. So we need to leave that names column header as it is and make sure there's always the sample names in that column A. But like
Mm.
before, columns B onwards, they're all our tracer data.
So yeah, you can
Yeah,
change them to as you wish. Yeah.
yeah. So the important thing here is to make sure that the headers of column B onwards are exactly the same as we had in the input one there.
Oh, so in the
Yeah,
same order and everything. Yeah.
yeah.
So
So it's best to copy and paste that columns F, the headers of columns F onwards, and then paste it into the sediments tab. Because if you put
yeah,
them in the wrong order or have one missing, the columns will line up wrong in the software, and it will start thinking one trace is another, and
tracer. Yeah.
yeah, it just
Yeah.
won't work. It'll be awful.
Yeah.
Cool. So yeah, all we'll do then is that if you wanted to replace this data, you'd put in your own names and then paste in all your own tracer data in columns B onwards. And once
Mhm.
that's done, you can go and click the save button on that input sheet. Yeah, and then just close the Excel sheet and cool, that's it. So all of our installing of the software and setting up the data and inputting our own measurements is done. The only thing left now is just to kind of run that software.